Today we're going to look at Group 2. In the Group 2 we have the alkaline earth metals. And to talk more about that, let's actually go across and look at the periodic table. All right, so here's our periodic table of elements. We're going to be focusing on Group 2. That's the second column on the table here. And these are all metals. We can't use all of them because some of them are very reactive. So we're just going to focus on magnesium and calcium. We call this the alkaline earth metals. A trend that you might see is that as you go further down the group, and that happens for all the metals, you'll find they get more and more reactive. So we should see that magnesium will go pretty slowly in its reaction with water. However, calcium should be able to proceed faster or even more vigorous reaction happening from calcium. Let's put them to the test. We'll get back to the bench. Here I've got some magnesium. And these are magnesium ribbons, and you can see that it has a bit of a dull shine because it tends to react with the oxygen in the atmosphere. We're going to clean it off in a minute with some sandpaper just to expose the bare metal, and that'll allow it to react a bit better with the water when that happens. We also got some calcium here. Calcium here is quite a bit more vigorous in terms of reactivity, so we've got in a jar here. And we've got very tiny pieces, so these ones are probably not going to show up on camera, so we're going to switch our camera to... We're going to switch our camera to macro mode in a minute, so we'll get a close-up. So let's do our first test here with magnesium. We're just going to drop it into some distilled water, so there should be no impurities in here. So we're just going to drop this in, and we're going to observe what happens for the next 5 minutes. Now that we have a close-up view, I think you'll find that there's quite a lot of these microbubbles all over the surface, and so we definitely have a reaction going on here. So let's sort of unpack what the reaction is. Well, the magnesium is reacting with the water, which is H2O, so 2 parts hydrogen and 1 part oxygen. And the magnesium is sort of displacing some of the hydrogen atoms out of the H2O molecule. And so these, ejected hydrogen atoms, they are forming hydrogen gas molecules, which is the gas bubbles we see on the surface. H2, that's what hydrogen gas is made from. And the remaining parts of the water that hasn't been ejected, that's going to leave behind some hydroxide ions, which is known as OH minus. And if you have a lot of these or very few of these present in the solution, that's going to affect the pH, the level of acidity of the solution. Okay, so it's been about 5 minutes, and now we're going to give it a pH test. So what we're going to add in here is a chemical we call phenolphthalein. And this is a pH indicator. It tends to change color quite vibrantly at a certain pH range. So if the pH, which is a measure of acidity, if the pH is neutral, so a pH of 7, right in the middle of the scale. In fact, the scale goes from 0 all the way up to 14. So 7 being exactly in the middle, it's a neutral. So ordinary tap water should be around pH 7. If you're anywhere between 0 and about 8.3 on the pH scale, this chemical will just be colorless. However, if it's higher than 8.3, so it's well and truly into the alkaline solution territory, we should see a very strong pigment of pink. So let's give it a few drops. Okay, so we haven't seen any chemical change there. So it should go pink because we should be making an alkaline solution. So what's probably happening here is that our reaction here is just going so slowly that we haven't had time to develop enough of the OH minus ions to get the pH of the whole solution to increase to 8.3. What we can do is we can grab this test tube and we're going to put it over a Bunsen burner just to warm it up a bit. So the reason why adding heat makes this thing happen a bit faster is because you add energy to each of those molecules of water to react with that magnesium, so we're getting a bit more contact between the two chemicals, the two substances, and we're starting to see this pink color develop, so that's the indicator that I was speaking to you earlier. Now we're going to turn our attention to calcium. Now calcium, as you recall from the periodic table that we were showing earlier, it's further down on the group, and we know that the reactivity gets a bit stronger as you get further down the group. So we should see calcium probably will go a bit faster reacting with ordinary water, and we won't need to require the assistance of heat to make this happen more quickly. So what I'm going to do this time is that we're going to try and capture the gas that's being produced, the little tiny bubbles we saw with magnesium. So as soon as I drop some in, I'm going to plug it with this. It's a rubber bung. with a hole through it, and we've got a pipe that leads us to a test tube. We might get my assistant here to get a better view of this test tube here. This whole test tube is filled with water all the way to the top. So as I produce gas from this test tube, we're going to funnel it all the way up underneath and into this inverted test tube. So any bubbles that are made will start to collect here one by one. And then we're going to do a bit of a flame test to see what kind of gas that is. Now, I've already given you a bit of a hint that it's hydrogen gas, but Mr. Bowman could be wrong, so we could do a bit of a flame test. If it's not hydrogen gas, you could blow the flame out, or it could just be a boring result. So we'll find out momentarily. Let's give this a shot. So I'm just going to drop in some calcium metal over here. This is still ordinary distilled water. And hopefully the camera can see if there's a change occurring down there. So now I'm going to add the seal, and then if the camera turns its attention to the other test tube here, we're just going to keep on collecting it. I'm just keeping some pressure here so the seal stays tight. We're now filling it up with whatever gas is being produced by this other test tube here, which is looking pretty violent. We're nearly filled here, so we might cut the video. Michael Mayer here, giving me some assistance to light my gas on fire. So let me see if I can retrieve this. So I haven't let any gas out, and on the count of 3, he's going to put it over the mouth here. 1, 2. That's definitely hydrogen. It always makes this sound. And you might even get a second. No, you don't even get a second shot. If we had carbon dioxide gas, the flame would just blow out. If the gas was oxygen gas, we should have seen the flame on his matchstick there just flare up and just get more brighter. But this time that sound is the characteristic sound of hydrogen gas. So what can we say about the group 2 elements? Well, they react with water. They react with water to produce hydrogen gas bubbles. And a byproduct is that water solution will start to go alkaline. So if I add the phenolphthalein, I should see much more intense pink this time because we've got far more, yeah, there we go. So we've still got a bit of a milky appearance because it's creating very many micro bubbles of hydrogen gas, so it's still going. I think that's about it. So that's all I can think of for now. So we'll check you in the next video.